right, this is the review for your normal distribution chapter. So we're going to first start with the empirical rule. And a normal distribution is always centered around your mean. So your mean goes in the middle, which is in this case 27. So 27 is my mean. I don't know why. There we go. And then you add to your standard, one standard deviation to your mean. So if I have a standard deviation of 2, 27, 28, 29 goes here, and keep adding 2. You keep adding your standard deviation. So your mean plus 2 standard deviations. Your mean plus 3 standard deviations. So 2 standard 29, 30, 31, add 2, 33, subtract 2, subtract 2, subtract 2, subtract 2 going this way. So subtracting 1 standard deviation, subtracting 1 standard deviation, subtracting 1 standard deviation. So 23 and 21. So, all right, so that's how you fill out your normal curve. Everything is symmetrical. 100% of the data lays underneath this normal curve. The empirical rule is an estimation. So it estimates that 68% falls within 1 standard deviation from the mean. And 95% falls 2 standard deviations of the mean. 95% of your data. 2 standard deviations from your mean. 2 standard deviations below, 2 standard deviations above. And then lastly, 3 standard deviations above is 99.7% of your data. And now if you're going to the whole normal curve, all the way to the very tip, that's 100% of your data. So since this is symmetrical, we can split our data up into smaller percentages. So since it's symmetrical, if 68% of your data falls within 1 standard deviation, divide that in 2 and you get 34 and 34, and then so forth. So you can just memorize these, you can put them on your note card, but all of these are your estimated percentages. So when we go to answer these questions, what percent, I can't read it. Come on, there we go. Of recruits are between the ages of 23 and 27. Well, 23 and 27 are right here, so in between are these two percentages put together. So 13.5% plus 34% will give me, and how it's written, let me write it correctly. So the probability or percent of recruits between the ages of 23 and 27 are 13.5 plus 34, which would give you 47.5%. What percent of recruits are at least 31? At least 31, that means 31 or higher. So starting at 31 and going higher. So at least 31 are those two put together, 2.35 and 0.15, which gives you 2.5%. Okay, approximately what percent of recruits at most 29? At most 29 means 29 or lower. So at most 29, so 29 or lower. That is, here's 29, so below it. I need to zoom out just a little bit. There we go. So it's all of these put together. And you can add all of them, or no, this is symmetrical, so 50% lays over here, 50% lays over here, because it's 100% of your data. So all I have to do is add all these together, or all of this is 50 plus 34, whatever is easier to you. I think most people just want to add all the little decimals, so that's what I will show you. This is a lot longer, but that's fine. So 84%. You would have gotten there a little quicker if you realized that this adds to 50 plus 34 is 84. But however you want to get there, you're adding all your different percentages. So this is one thing that needs to be on your note card, is all of these percentages. Okay, so that's the empirical rule, which is an estimation. Z-scores. A Z-score is standardizing your data. So the blood pressure of a group of adults is normally distributed with a mean of 121 and a standard deviation of 3. Mean or average is this symbol, which is mu, 122. Standard deviation is this symbol, which is 13. If Mina, I don't know, blood pressure is 108, that's just a data, she is 108, find her standard deviation. Well, 108, if you think 122 is in the middle, 108's below that, so she's gonna have a smaller, a negative Z-score. But the formula for Z is your data minus your mean divided by your standard deviation. So to write that out, it's your X, your data, your sample, whatever it is, minus your mean over your standard deviation. So we have it all. X is 108, your mean is 122, and your standard deviation is 13, and you're putting that all in the calculator. Make sure you do 108 minus 122 first, because that's negative 14 divided by 13 gives you negative 1.076. And we're going 2 decimal places, the hundredth, so the 6 bumps it up to an 8. So our Z-score is negative 1.08. That means she is below the mean by a little more than 1 standard deviation. What is the standard deviation? All right. Standard deviation is this formula. I put these formulas on my note card. It is your X minus your mean divided by your Z-score. So a length of a certain species is normally distributed with a mean of 15 centimeters. If the fish in this species is 18.8 centimeters with a Z-score of 1.9, what is the standard deviation? So 18.8 minus, I'm filling in this equation, 15 divided by the Z-score. You're good. So again, make sure you're either hitting your fraction button with like the alpha y equals enter, and we're doing the top divided by the bottom. So this is 2 centimeters. So these are the 4 equations for this part. So if you're finding the mean, this is your mean. And so you need to know what all these symbols are. Mu is your mean, X is your data, Z is your standard deviation or your Z-score. I'm sorry, Z is your Z-score, and sigma is your standard deviation. Okay, so when we're finding the mean, we need to use this equation. The mean, mu, equals your data minus your Z-score times your standard deviation. So daily balance in your account, course of the month, has with a standard deviation of 84.10, and the balance on the particular day, so X, 317.34, with a Z-score of negative 2.4. Careful with that negative. So filling everything in, 317.34 minus negative 2.4 times my standard deviation. And then just put that all in the calculator all at once. 2 negatives make a positive, so this number is going to go up. So the mean is $519.18. How many more times did Mindy visit the gym than Kirk? So we need to know Mindy's X value and Kirk's X value, Kurt's, so we can subtract them. So we need to figure out their data. So we'll start with Mindy. The mean is 97. The standard deviation is 25. Kurt's Z-score is negative 1.8. and Mindy's Z-score is 2.4. So Mindy, her Z-score, I'm filling in this equation, Z-score is 2.4. Standard deviation is 25 plus the mean of 97. Gives me a X value of, and then put it all in the calculator at once, 157. And then we'll do the same thing with Kurt. So his Z-score is negative 1.8. Still the same standard deviation, 25, plus the same mean of 97, all in the calculator at once, is 52. So the number of visits for Mindy is 157, and for Kurt is 52. So how many more times did Mindy visit the gym than Kurt? 157 minus 52. She visited the gym 105 more times than Kurt.